So today we are going to discuss on part 7.3 super, this, covariant returns and override versus hide. So super keyword, it allows a child class to access members of its parent class in two main ways. First, super is used to call the constructor of the parent class. This call must appear as the very first statement in the child constructor. If you do not explicitly write super, the compiler automatically inserts a call to the no argument parent constructor. However, if the parent class does not have a no argument constructor, the implicit call results in a compile time error. We have to understand this, okay, very clearly. Second, super.method name allows a child class to call parents version of a method. So this is often used inside an overridden method when you want to extend parents behavior instead of completely replacing it. For example, a dog class overriding the speak method might first call super.speak to execute the animal version of the method and then add its own additional output. It is important to note that super can only refer to the immediate parent class. Java does not allow chaining like super.super.method to directly access a grandparent class. So this is a very good concept, we have to remember it. So if you see the example code here, this example demonstrates inheritance constructor chaining with super and method overriding. First, we define the parent class animal. It has an instance variable called name and a constructor that accepts a name and assigns it to the field. The class also defines a method called speak, which simply prints animal followed by the name. Next, we define the child class dog, which extends animal. This means dog inherits the fields and methods of animal. The dog class adds a new field called breed. Okay. So now look at the dog constructor. Dog, string name and string breed, right? So the first statement inside the constructor is super name. Okay, this calls the parent constructor animal string and it initializes the inherited name field. A very important rule in Java is that super must also always be the first statement in a constructor. After that, the constructor initializes the breed field using this breed. Next, the dog class overrides the speak method. The @override annotation tells the compiler that this method is intended to replace the parent version. Inside the overridden method, the first line is super.speak. This calls the parent class version of speak, which prints the animal's name. After that, the dog class adds its own behavior by printing the breed. Finally, we create a dog object like dog D is equal to new dog Rex Labrador. Then we call d.speak. Execution happens in two steps here. Okay, super.speak prints animal (Rex) and the second print statement outputs breed (Labrador). So the final output is animal (Rex) and breed (Labrador). Okay. So current instance and constructor delegation, right? So this keyword refers to the current object instance, the object on which a method or constructor is being executed. When used with parentheses as this, it calls another constructor in the same class. This technique is known as constructor chaining or constructor delegation. Like super, the call to this must appear as the first statement in the constructor. It is commonly used to avoid repeating initialization code across multiple constructors. Okay, we have to remember this. Understand this. This is very important. The expression this.field name is also used to distinguish between instance variables and parameters when they have the same name. For example, in the statement this.name equal to name, the left side refers to the instance variable. While the right side refers to the constructor parameter. Okay, so if we see the example code here, this example, it demonstrates three important uses of the this keyword in Java: constructor chaining, field distinguishing, and the restriction in static methods. The person class, here we define a class called person with two instance variables, name, age, right? Name comma age. These variables hold the state of each person object, and we have a constructor person string name, this name comma 0. This constructor takes only the name. Instead of repeating initialization logic, it calls another constructor in the same class using this name comma 0. This is called a constructor delegation or a constructor chaining. It passes the name along and sets the age 0 to 0 by default. A very important rule is this must always be the first statement inside a constructor. Okay, person string name, then we have second constructor person string name comma int age. This constructor initializes both fields. Inside it we see this.name equal to name. So here this.name refers to the instance variable while name refers to the constructor parameter. This this keyword here, it helps distinguish between the two variables with the same name. Okay, the same pattern is used for age. This.age is equal to age, and the display method is void display system out dot println this.name then comma this.age, right? This method prints the person's name and age using this name, and this.age explicitly refers to the fields of the current object. Okay, so covariant return types. So covariant return types are a feature introduced in Java 5 that relaxes the earlier rule that required overridden methods to have exactly the same return type. With covariant returns, a child class, when a child class overrides a method, it may return a more specific subtype of the return type declared in the parent class. For example, if the parent class defines a method that returns animal, child class can override that method and return dog, because dog is a subclass of animal. This works because any code expecting an animal can safely receive a dog. Okay, and however the opposite direction is not allowed. An overriding method cannot return a more general type than the parent method. Okay, so let's look at the code, right? So let's look at the covariant return types using three classes. We start with parent class animal. Its create method returns an animal, simple enough. Now dog extends animal and overrides create, but instead of returning animal, it returns dog. So this is allowed because dog is an animal. It is more specific type, not a defined one. Any code that expects an animal back is perfectly happy receiving a dog. This is a covariant return. The child narrows the return type and Java allows it. Now look at cat. It also overrides create but returns object instead. Object is actually higher up the hierarchy than animal. It is more general, not more specific. The parent promised to return an animal, but cat is now saying it might return anything at all, right? So that breaks the original promise, so the compiler rejects it. The rule is very simple. You can go narrower, never wider. Animal to dog is fine, is narrower allowed, but animal to object is wider. It will lead to compile time error. Okay, so static method hiding versus instant method overriding. So the difference between method hiding and method overriding is a common topic on the exam. When an instance method is overridden, it participates in dynamic dispatch. If you call the method through a parent reference, Java determines which version to run based on the actual object at runtime. This behavior is known as polymorphism. Okay. Static methods work totally differently. Static methods belong to the class itself, not to an individual object. If a child class declares a static method with the same name as a static method in the parent class, it does not override the method. It will hide it. Okay. So because static methods are resolved at compile time, they do not participate in dynamic dispatch. If you call a static method through a parent reference, even when the object is actually child object, Java will execute the parent static method. In other words, the method that runs is determined by the type of reference variable, not by the actual object type. Okay. So if we see the code, we have a parent class with two methods, a static method and an instance method. Child class extends parent and defines both methods again. The instance method has @override on it, and the static method does not, and that is intentional because you cannot override a static method. Now we create the interesting line. So parent ref is equal to new child, right? So the reference type is parent, the actual object in memory is a child. Keep both of these facts in your mind as we call the two methods. So first call ref.instance method. The compiler looks at the reference type parent, sees that the instance method exists and allows the call. At the runtime, Java looks at the actual object, which is a child, and calls child's instance method. This is dynamic dispatch. The output is child instance. Second call, ref.static method. Here is where it gets defined. Static methods belong to the class, not to any object. There is no dynamic dispatch for static methods. The compiler sees the reference type is parent, resolves the call to parent static method right there at compile time, and that is the end of it. The actual object being a child makes no difference. The output is parent static. This is called method hiding. Okay, child static method exists, but it does not replace parents. It simply hides it when called through a child reference. And the third call, child c is equal to new child, c.static method, right? Now the reference type is child, so the compiler resolves it to child static method and the output is child static. Then we have static method hiding versus instance method overriding. Okay, now the practice question, right? This practice question combines both concepts we just covered, static hiding and instance overriding, in a single main method. So let's trace it line by line. We have base with two methods. Tag is static and name is an instance method. Class sub extends class base and defines its own method tag. Again, it's static and overrides name with @override. Now the key line, base b is equal to new sub, right? So reference type is base, but actual object is a sub. First call b.tag. Tag is a static method. Static methods use compile time dispatch, and Java looks at the reference type only. The reference type is base, so base's tag runs, right? Base's tag method runs. It returns base and then gets printed, right? So the fact is that the actual object is a sub is completely ignored here. Second call b.name, and name is an instance method and sub has overridden it. So Java uses runtime dispatch. It looks at the actual object, which is a sub, and calls sub's name. It returns sub and that gets printed. So the output is what? Output is base and sub. So we have more questions, 1624 questions at https://javalearn.clustermicro.com. You can practice all that you need, and we have 29 full-length practice tests there, and those are fully cloud native using modern databases and with really great explanation there. Thanks for your time.